Good afternoon, everyone. I'm Mike Warlick. I'm the Vice President for Defense for FC International, and I want to thank everybody for joining the conference this week. It's been a lot of fun kicking off the day. There's a lot of activity, as you can see, around the building, and it was nice having Admiral Norton kick this thing off for us today. It's my pleasure to introduce Mr. Fred Ruonavar, Chief Mission Assurance Branch, DISA, DoDIN Critical Infrastructure Protection Program, Defense Information Systems Agency, as you might expect. A little bit about his background, and I'll tell you what he's going to talk about. Along with his title, he's also the lead for DISA and the DoD Information Network, Sector Critical Infrastructure Protection, Program Reporting to OSD, a technical advisor on matters involving ongoing programs, organizational structures, and evaluating deliberate and contingency plans, policies for use by DoD employees in the development of information technology criteria, and that's just to name a few of his responsibilities that are outside his actual title. He's a subject matter expert for critical information protection, which we hear about almost daily anymore, and we're going to hear even more going down the road for the DoD, and he also serves as an advisor to the National Security Council and other DoD and OSD organizations. So he has a broad reach, and I think you already know that DISA has a broad reach to start with. His topic this afternoon is DISA's Task Critical Asset Nomination Process. Please join me in welcoming Mr. Fred Ruonavar to the podium.
Thank you very much. So good afternoon. Are we all wide awake? So if this gig doesn't work out today, I'm going to get right into singing and dancing to keep you entertained. So if I get a lot of this coming back at me, I might just start singing and dancing. Now that would be very, very painful. Right, Nikki? So, greetings. So, you know, one of the things we look at within the Department of Defense is that every single combatant command has a contingency or operational plan that they're responsible for. The services and the components actually have capabilities then that bring to bear to execute those lines of operations on those deliberate planning efforts. So we might think of, you know, how we within the Department of Defense marry all this together to look at the seams and gaps associated with the different mission sets and the different capabilities that are brought to bear to support that. So inside of my portfolio, I have, under mission assurance, I got critical infrastructure protection, supply chain risk management, and international cyber development. So it kind of cuts across the full spectrum of operations. I have to understand the salient features of every single one of the con plans or op plans that DoD has. What are the specific requirements and capabilities that they need to execute those plans, and then how do we tie it all together? So over the course of the next hour, if I don't have to jump into singing and dancing, I'm going to go through some of that stuff with you so that you can see how we at DISA do this and how we integrate this back in at the OSD level to get the right funding strategies associated with meeting those mission requirements for DoD. So I'm the bald-headed guy up at the top. I'm Mr. Ruonavar. I'm the Chief of Mission Assurance. Underneath me, I have two different branches. I have the Chief of Plans and Analysis, and then I have Risk Management. And then underneath that, I have Critical Infrastructure Protection, International Cyber Development. So I actually teach a course at Talent at the CCDCOE on Critical Information Infrastructure Protection. We've also taught it in the Pacific and Japan, and we'll do it in Portugal sometime in the fall as well. Then we have supply chain risk management, and that's everything from what we're procuring, how we're procuring it, where it goes within our infrastructure for C4I, and how that supports the warfighter. And then last but not least, it's looking at assessments and how we support the DTRA balanced survivability assessments, the JMAR assessments, the service level assessments, for example, the OPNAV, and those assessments that are happening. There's a key member for comms that supports those assessments, and they are on my team. So somebody from my team actually goes out on those assessments and looks at that, and they bring it back into our vulnerability analysis back to DoD. So where do we get our authority? So these are just a couple examples, but it starts with PPD number 21, that you have to identify your critical infrastructure program. You have to identify those critical mission capabilities that you have. And then from that, you have to be able to look at that critical infrastructure, prioritize it, manage it. And so we get our direction from those two documents, DoD Directive 3020.40 and DoD Instruction 3020.45. We fall directly underneath the DoD CIO, of course, through Admiral Norton, and I work for Mr. Larry Closter, who's an SEAS. He's the Critical Information Assurance Officer for DISA, and we run all those reports up through him, Admiral Norton, up to OSD. So right to the heart of it. Back as far back as the Roman Empire, there was critical infrastructure. So if you look at the aqueducts going into Rome, you would say that was pretty important critical infrastructure. But before the aqueducts were built, there was actually a water distribution system going into Rome. Rome at the time was the largest city on the planet with over 1 million people living there, so fresh running water was important, not only for drinking and for bathing, but for also processing waste. So for hundreds of years, that system that distributed water wasn't displayed to anybody. As the Roman Empire became more opulent and as they became more advanced, it was very important to have these edifices sitting out there that people could see just how great Rome was. So the aqueducts became a critical component of showing the world this is what Rome is, this is what we bring to bear. But more importantly, those aqueducts were important for bringing water into Rome. So in 410 AD, when Alaric sacked Rome, the first thing they did was surround the city of Rome. The second thing they did was they cut off the water supply going into Rome. And it was easy to do because they just cut off the water through the aqueducts. So it's like choking the life out of a city when you take the water or food away. And it was easy because now that critical infrastructure was identifiable because it stood out along the Appian Plain and the Appian Way going into Rome. And that's similar to today on our critical infrastructure. So as you look at the mission assurance framework, you have to look at what are all those capabilities that we have and we bring to bear. So there's a saying by Frederick the Great, those that protect everything protect nothing. You can't boil the ocean. You can't hold all the sand on the beach in your hand because everything's going to slip out. But what you can do is identify those systems and capabilities that are most important. So in mission analysis, you have to understand, what must we be able to do? What is the mission set that the services are bringing to bear? Is it a land, sea, air operation? Is it force maneuver, force capability, supply distribution? Those are different mission sets. And then what are the Tier 1 plans that need to be supported based on those capabilities? And as we look at that, what phase of the operation are we in? If we're in phase 0, we're in peacetime, there's a set of requirements and capabilities that are brought to bear. For example, getting on Facebook, ordering supplies on the internet, which are at peacetime as just as important as sometimes even making command and control telephone calls. When you go to a different phase of operation, then those things become a little bit less important and other capabilities become more important. And last but not least, we look at what are the assets that we need to do and execute those mission spaces. So this is a whole of DoD approach to analytics. So every combatant command, every service, every agency has to do this assessment of their capabilities. We within the Defense Information Systems Agency have to do the same thing because we are a combat support agency and we're a force multiplier and force enabler based on the capabilities that we're bringing to bear. So again, what do we have to support? What are the C2 requirements, for example, that we need to support with? How much bandwidth is needed to do that? I will tell you, in the course of the last 20 years, the bandwidth requirements supporting DoD has more than quadrupled, and it's only going to get more intensive over the course of time. 25 years ago, when I was in the military, we had less than 25 different applications that we use. Today, there's over 15,000 different applications that the warfighters are relying upon to execute their mission space. Some of them have very intensive bandwidth requirements. Some of them have very minimal bandwidth requirements, but they rely on low latency. All of those are quite a bit different. They're hosted in data centers and data services all the way across the planet. Some are close to the warfighter. Some are hundreds of thousands of miles away from the warfighter. So as we look at this, those are the things that we have to take into account. So then we have to look at the other things that those assets rely upon. What are the capabilities that we would need to execute those lines of operation for communications to stay up and operational. Who are the vendors? Where are we getting this service from? What does their infrastructure look like? Who are they reliant upon? So almost any telecom vendor does not provide service all the way across the planet on their own bandwidth. They rely on sub-vendors, they rely on different equipment sets, different capabilities to get it from point A to point B. What are their interdependencies? Those fiber optic repeaters that are running through the middle of the ocean or a desert or across the land, they have a requirement for power. How much power do they need? How much power do they have on hand if the power to the grid is shut off? How long will the batteries operate? How long does the fuel supply work? And all that is a necessity to understand how survivable we really are as we build out our infrastructure. And oh, by the way, this is a whole of government approach. I just gave you an example of how telecommunication relies on electricity, but I will tell you telecommunication also relies on transportation. And you might shake your head and you say, because a few years ago we started looking at the roads and rails of the different countries that our service members are deployed into. And I was asked by somebody very senior in the Pentagon, so why does DISA give a hoot and darn about, I had to really clean that language up, by the way. Nikki's really impressed with me. She said, boss, you nailed that one. But why does DISA care about transportation? Well, it's pretty simple. If you go outside of almost any installation across the globe and you drive on the road getting on there, you can actually see the markers where there's telecommunications that ride along that road. Almost every road across this planet, and that's in almost every nation state across this planet, they actually put the fiber distribution system in along the road because it's easy to get put in. It's also easy to repair once it gets damaged. And oh, by the way, your electrical power lines do some of the same things. As you go outside the camp post stations, you can follow the electrical distribution system, which also is tied into the telecommunication systems, which is all along the roads. So as we look at this, these are all sets of interdependencies. So as we look at the whole nation state responsibility, each one of these different sectors has done a critical job in assessing those capabilities. We then have to tie that analysis back into what we are doing for survivability. So I talked about this a minute ago. Why it matters? 1.4 million active duty service members deployed across this planet. Everything from Southeast Asia to Southwest Asia and everything in between are our customers. Over 130,000 deployed troops in 150 different countries with nation partners, 60 different allies and partnerships supporting the air, land, sea, and of course now the cyber domain, with 15,000 different applications being used. When I went into services back in the 70s, we had to learn how to read maps, right? And that became a very core component of understanding the terrain and where we were deploying to and how we'd get from point A to point B, how we would defend that terrain. Well, now it's on an application. Now it might be on a smart device or tablet, and our guys and gals are going out in the field, and they can actually very quickly and articulately determine where they're at, where they need to go, and even where the adversary may be targeting them. That's an application based on a capability that relies on the telecommunication services that we're providing. So now I'm going to talk about task-critical assets. So these are the assets within the Department of Defense that, should you lose them, you would have a mission failure based on the loss of that capability. So if you have a Tier 1 task-critical asset, you basically means it's a single point of failure. And I'll give you an example of a blue widget and a pink widget, right? So if you have to have a blue widget factory to create blue widgets to defeat a pink widget, and that's your only widget factory, that is a Tier 1 task-critical asset. Because if you lose that ability to create those blue widgets, now all of a sudden you can't execute that line of operation. Important to that factory then would be all of the subsystems associated with its survivability. The power, the transportation, the telecommunications. All of those systems put in together to make sure that that mission is executable. That is a Tier 1 TCA. If it is so important to DoD, that becomes a defense critical asset. And that's up at the chairman, SecDef level to say, you know, these are things we have to fix. Or these are things that they're so important we need to make sure we have the right level of security, the right level of capability, the right level of support for that. Oh, by the way, and Tier 2 TCAs are things that several things can go wrong. Within telecommunications, we look at this all the time. That fiber-seeking backhoe that took out a fiber someplace that was not supposed to have an impact. But the reality of it is there was another cable that ran real close to it that was taken out. And oh, by the way, the two cables being that close together, they're still survivable, but you know, the bad things never happen. A fiber-seeking backhoe never takes out two cables at one time. But we track those because that does happen sometimes. So anyways, those are several things have to happen to cause an outage. So now we're looking at the DoD, and now I'm talking about the big Department of Defense, mission assurance strategy and how we get at this stuff, right? So now there's a three-phase process that the department uses to analyze what's important, where the vulnerabilities are, and what do we do about that. And this is the job that we do within DISA all the time. First, the department has to identify what are those critical camp post stations across the planet, what are their mission sets and capabilities, how do they bring that stuff to bear before we can do our job. Once they've done that, then we get back into what are those systems and capabilities. So as we look at the mission owner might be a Air Force base that has a specific capability that they've nominated. We then would take that mission asset and we would say, okay, what are the capabilities they need to do to execute that line of operation? So once that is done, then it goes into that hazard, all threats and hazard vulnerability assessment. Are there a lot of fiber-seeking backhoes operating in that area? And I will tell you, there's just as bad as about anything on this planet after being in communications for 40 years. They're our worst enemy. Misutility is our best friend. Unfortunately, misutility doesn't necessarily work in the middle of the plains in Nebraska when we need them to. All that being said, that all threats and hazard approach are things that we'll talk about here in the next few slides on how we assess that stuff so that we can make the right assessments so that we are survivable and we have the right level of diversity, capacity for survivability. All this then gets down to the end where we talk about the risk mitigation, right? So now we're talking about what do we do once we know we have an asset that's very valuable, we have threats and vulnerabilities, and now we get into the risk mitigation. Do we leave the risk the way it is because it's just too expensive to fix? Do we put things in place like satellite connectivity for some survivability? Or do we just run new fiber paths? Those are all examples of how we get at these risk decision packages. And oh, by the way, it has to fall within our financial framework to do these things. And that's what the department does all the time. A few years ago, the risk decision was made that, you know, we really need 900 fighters, or we really need X amount of carrier battle groups to do these jobs. But the reality is we don't have the funding to do that. So the department had to make the decision, the United States government had to make the decision, this is what we're going to live with today, and these are the things that we can support. Those are risk decisions. So now we get into what's important and why. Looking at mission analysis side of the fence is really important. And it's also one of the most difficult things that we do. And you would say, well, no, that's pretty easy because we know where our forces are at and we know where they're going to deploy and we really know what they're going to do from one given minute to the next. But I will tell you, that actually becomes one of the most difficult things to do. So if you think about the operations of the United States military, all the way from Southeast Asia to Southwest Asia and everything in between, you understand that there's a whole bunch of different mission requirements and capabilities that are brought to bear. Let's look at, for example, combat operations today as they exist in Afghanistan or even supporting the coalition in Iraq. That is a direct engagement, direct capabilities with warfighters on the ground. Tomorrow, there may be a typhoon or hurricane or an earthquake that happens someplace, and you have a humanitarian disaster relief effort that needs to take place. Now, all of a sudden, that's got to take priority too. That has its own set of mission requirements and capability. So that gets into that mission analysis and deconfliction on how we have to tie that back into what do we need to execute all those different lines of operations? What is that critical asset list to do that? So the department has already laid that out. We within the department, DISA, we have to lay out our critical infrastructure that supports that. Enough bandwidth on time to deliver the capabilities to support all those 15,000 applications wherever it may be. So next we get into threats and hazards. And this actually is one of the areas where we look at, do we have the right level of diversity? Not only do we have the right level of diversity, are we using the same vendor going onto the camp post station? Are they 10 miles down the road all going over the same bridge? Do our adversaries or do terrorist organizations know where that infrastructure is, and are they planning to do something against it? All of those capabilities then roll into our vulnerability assessment of just how vulnerable that system may be. So let's talk about the Blue Widget Factory again. That Blue Widget Factory is so important we can't live without it. That Blue Widget Factory may be sitting on the top of a mountain. It's a granite mountain. You can't just put fiber in the ground going up to the granite mountain because it's very expensive. It's a ways away from everything. So the risk decision may have been, you know what, we could live with just running that stuff on a pole going up to the top of the mountain because it's the cheapest way to get it there. But it's in an area that does not have a lot of big storms. It's in an area where there's not an adversarial attack present that may happen anytime soon, or that a terrorist organization may target because it's in the middle of nowhere. So the thought process would be, you know, you can live with that risk because the other things associated with it may make it less vulnerable. But that changes depending on where you're at. If that Blue Widget Factory is someplace that is on an active tectonic plate zone, where you have a lot of earthquakes, or there's a lot of tropical storms or hurricanes, or it's in an area where we're in conflict and conflict operations are happening and adversaries may be looking to target some of our systems, that changes that risk matrix quite a bit for survivability. And that then goes into our vulnerability assessment and readout. So as we look at this, then, we look at what is the mission, how critical is the mission, what is the vulnerability, and what is the likelihood that that vulnerability is going to result in mission impact. So if it's so valuable we can never live without it, if that Blue Widget Factory is the system that has to always be on and operational, then that ties back into, okay, we have to have connectivity no matter what all the time. Then if you get into that, well, you know, really the mission requirement based on that, even though it's important, it's not that important, and there's a lot of risks, well, then we can live with the risks because it's not going to impact a direct operation. These are the decisions that we have to make when we get back down to that risk decision package and nominating that up to OSD. Understanding what we're providing, where we're providing it, who we're supporting, what would be the mission impact if that is lost. That then gets back into the mission assurance framework for survivability. Now I'm going to give you a couple examples. This is not my latest artwork. I actually do a little bit better than this. But this is a visualization of the internet as it exists today. So this was done by JPL, but it ties together all of those systems that are around this whole map, from the satellite networks to the data centers to the undersea cable network to the terrestrial networks as they exist today. Whether you believe it or not, this is your internet. If you did not have the undersea cable network as it exists today, you would not have a connected global internet connecting to everything. You say, well, wait a minute, Mr. Ruonavar, you got this satellite network that's up there pumping all kinds of traffic. The most advanced satellite systems on the planet today cannot support cable systems that were put in the water 20 years ago. The most advanced satellite systems that will be placed in 10 years from now will not be able to meet the bandwidth capabilities of the undersea cables that were put in the water 20 years ago. Think about that for a minute. Your big bandwidth connections that support Google, Facebook, Microsoft, those content providers as they exist today would not be able to deliver those service platforms if they were using a geospatial platform to do that. So this becomes very important to the world economy. And I can go down the list of all the things that's said on this slide, but take into account there's a lot of undersea cables, there's a lot of cable landing stations, they're owned and operated by consortiums, and they're connecting on almost every single country that's got water connecting to it across this planet. So, let's talk now about, now we're talking mission assurance. And I'm just giving you an example of one of the mission assurance frameworks that we're sitting in today. This has been in the news an awful lot. As a matter of fact, if you look at the advertisements associated with Google, Facebook, Microsoft, you will see that they're actually involved in laying cables in the water. They're actually buying fibers on these cables. So it's very important to their business portfolio. $10 trillion of business goes over the undersea cables daily. $10 trillion a day. They carry 97% of all the global telecommunications. That's in 2015. And oh, by the way, as we get more advanced, as those bandwidth requirements continue to grow, that's going to go from 97 to 98 to 99.99. And the reason being is because as you do the articulation for your data flow across this planet, those big bandwidth requirements, Google, Facebook, Microsoft, their data centers may be sitting in Sweden, in Finland, in Denmark, and the Netherlands, and they may be doing a data transfer from someplace in California. And oh, by the way, maybe the data of everybody that gets into Google and does anything as far as a Google search on how they get to one part of the planet to another. And those requirements will only get more advanced as our technology and capabilities grow. So as you go to a 5G network, as you go to your next generation of televisions that are, I don't know, 3D that in the room when you turn them on, not that I really want that because I'm already afraid of the stuff that's on TV. But as you get to that, think of the bandwidth requirements associated with that. So as you look at the importance of the undersea cables, you have to understand they are, one, not owned and operated by the government in almost any country that you're in. They're owned and operated by consortiums. They're being put in the water at an exponential rate. And oh, by the way, their capability is growing at an exponential rate. The cable system that were put in the water about 10 to 20 years ago only had a 2 to 5 terabit capacity. The new systems coming out are going to have 200 to 300 terabit capacity. There's a good side and there's a bad side to that story. The good side is, wow, look at the capability that you are now going to have for delivering that global internet footprint. But the bad side of it is, you know what? We can do a lot less. We can do a lot more with a lot less cables in the water. 17 cables between the United States and Europe. You can Google this and find it, and I'm not telling you nothing that's classified. I will tell you that in the next probably 10 years, there's going to be less than 8 undersea cables between the United States and Europe. They become more and more important as we get more and more technologically advanced. That is a mission assurance framework for the global internet as it exists today, for finance, for treasury, for DoD operations. Understanding that then becomes really important. And oh, guess what? There is an outage every single day on an undersea cable system someplace. I love fish. Looks like I love a lot of things, but I do like fish. So those fishing trawlers that are out there running their nets and dragging their nets are one of the biggest damaging factors we have to undersea cables. But also anchor drags, right? So those big ships. And at one point I thought, well, I've went fishing a time or two. I don't think my anchor could actually damage any cable. Well, Fred, our anchor's bigger than your whole boat. So those big 10,000-pound anchors, when they hit the bottom of the seafloor, can do a lot of damage. How many folks in the room remember the undersea cable outages that we had in the Mediterranean back in 2007, 2008? We got a couple hands. Nobody else remembers that stuff? Well, I will tell you, that was a couple anchor drags, right? Bad storm in the Mediterranean, ship bouncing around, anchors bouncing around, boom, 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 busting up cables. Didn't impact DoD as much, but what I tell you, had a big impact to the commercial community. A vast majority of the undersea cable outages that happen within 1,000 meters of the shore. And again, it's because of all the stuff that I just talked about. When you get into deep water, and I mean deep water that's 1,000 meters, 2,000 meters deep, not a whole lot of ships have their anchor dragging that far. I'd like to see the anchor if they did, but all of those deep water outages that do happen, I will tell you, those are faults on the cable systems as they exist. So each undersea cable system consists of 4 to 30 different consortiums that are built together. Some of them are telecom companies that do this business. 99% of them are non-government owned. That means industry drives this business. Industry drives the internet. Industry is the one that puts this stuff in the water. Industry is the one that ultimately is responsible. And you'd say, well, why did we do that? Well, because industry doesn't want to lose money. Some of the vendors that are in a room will say, you know, this is pretty important to our business, and we don't want that stuff to go down. So industry takes a lot of protective measures associated with this. Cable repairs, as they happen, are flagged. That most of these ships are not flagged by the United States government or any major government, just like any of the shipping industry. And some of these outages on these cable repair ship can take anywhere up to 45 to 60 days to get out to fix the cable. So now you're getting a general gist that there's a vulnerability and there's a threat associated with just natural disasters, and then how long it takes to fix the cable systems as they exist. Facts you need to know. There's 56 of these different ships across the globe, and you might say, well, that's quite a few. But of the 56 ships, about a third of them at any one given time is actually deployed putting cable in the water. And that may be a cable going across the ocean, or maybe a festoon cable along the shore. Long story short, this is a busy commodity. They require a specialized crew to do this business. Specialized training, and you see the places that they're licensed to operate out of. So let me get past this real quick and get into this, and then I'll get back to that in a minute. So as we talk about Tca validation, this is a full frame cycle of what we need to do. So we start at the top with the combatant command, service and agencies, identify those critical mission sets. We then look at that infrastructure that DISA provides to support that. We then develop a strategy for analyzing those task critical assets and submitting that up to OSD for submission. And oh, by the way, we do this in-house in DISA. So we don't just dump it back over to OSD. We actually will take this in-house and say, you know, we got a problem, we got a vulnerability that we need to fix. And our engineers will start working on this near term instead of waiting to get 5 years into a budget cycle to fix it. Then we develop a strategy for how we're going to do that. And if it requires funding, if it's in a granite, and that granite's going to require a lot of money to lay that cable, then we have to get that palmed into a budget cycle, or we need to put in an urgent funding requirement to do that. Long story short, this is the whole process and cycle for developing a strategy for analyzing the mission, understanding the vulnerabilities, getting fix actions in place, and getting it funded. To do this, our group in the Mission Assurance Branch does a bunch of assessments. I told you a few minutes ago that we work with DTRA, the Joint Staff. We work with the service components. But we do a set of analysis. So we've looked at different undersea cables and cable landing stations as they exist. We do supply chain risk management assessments of the capabilities that are on the commercial POPs at every camp post station across this planet. We also look at the countries that we are in. So we'll do a set of characterizations based on the as-is known architecture that we're leasing on, and we're looking for seams and gaps and vulnerabilities. We support the different combatant commands with these, as well as international partners as we look at this stuff. And then, of course, we do our TCA submission. I'm going the wrong way, ain't I? I can go through this again and talk in reverse. I couldn't even say question in reverse. So all that being said, you should have a better understanding for the framework of DoD's mission assurance strategy and how DoD works as a whole. And then a better understanding for how DISA fits into that puzzle of mission assurance, analyzing the different mission sets and capabilities, and then looking at the C4I systems that support that. For the most part, this briefing, when I give it, is at a classified level, so I've had to cut it short. So there's a few times there's slides missing and things that I didn't say. I hiccuped when I got to them. Nikki put her hand like this and looked at me. You guys didn't see that in the back of the room. But I'll open up the floor for questions, concerns. Sir.
Use the mic, please.
Could you use the mic?
Why are the number of cables going down to 8?
So what happens, and again, that's not necessarily what's going to happen, that's just an industry standard that we see, because what's happened over the course of time, the cables have gotten much better, the bandwidth has gotten much higher. So instead of needing 17 cables, now 2 or 3 cables have that same amount of capacity. So it's an economical standpoint. Oh, by the way, the economical standpoint of putting cables in the water and their validity is associated back to a profit margin. So the vendors put cables in the water based on being able to make money. That's what this is all about. So if it does more, you do it with less. And oh, by the way, that cost point for bandwidth has gone way down. So say it used to cost, and this is an example, this isn't the honest truth, but say it's an example, say it used to cost $100 for 1 megabit. Well, now it's probably $3 for a megabit. So the cost point margin associated with that's went down as the requirement has went up, but it hasn't gone up in the same growth rate pattern.
So what do you do with the old cables?
Well, that's an industry does with the old cables. DISA doesn't do anything with them. But a lot of those cables are pulled up or repurposed for other things. Any other questions? You guys want me to sing and dance now? I tell you, I do a mean Frank Sinatra. Even a better Dean Martin. All right, guys, thanks. Oh, I'm sorry. By the way, I normally get the question, how often do you shave your head? Every single night. It takes work to be this good looking. No comments on that, please, and no questions. Sir.
Hey, sir. I'm Scott Barrington with ServiceNow. It looks like a really complex problem set that you got there. I guess I don't need to tell you that. It's probably why you don't have a lot of hair right now. But what are you looking for from industry, or what are some enablers that can help you to manage this complex problem set that you've got?
Boy, that's a good question. So, you know, one of the challenges that we have is understanding the infrastructure and architecture that the commercial telecom vendors have, period. So that is their guarded secret. That's what keeps them in business. That's what keeps them competitive. My understanding of that helps me make the determination on a survivability metrics on what we can use and what we need to use to diversify that portfolio. As far as tools and capabilities, we're always looking for tools and capability to make this a little bit easier. By the way, this whole mission analysis portfolio that I have, supply chain risk management, international cyber development, I'm doing that with about 10 people. So anything that we have that would add to that capability would definitely allow us to do things a little bit smarter, a little bit better, a little bit faster. The integration of data sets as they exist from what the services and the components have might also help, right? So that integration, being able to pull that metadata into like the mission assurance, decision support system, those sort of things, that would definitely help us be able to analyze what the capabilities that they already have, what they're using, and how we can bring that to bear. I don't have a concrete answer for you, but I tell you, I meet with probably a vendor once a week or every other week, and they have an idea. Some of them are really, really good. I wish I had a bunch of money. My wife has all my money, and what she doesn't have, my ex-wife has. I know, it's a terrible story. I can go into that, but somebody's going to throw something before long. That's why I shaved my head. Anyways, hope that answered your question. Any other questions?
Not to dive literally too deep more into the cable scenario here, but when we had the earthquake over in Japan and they had the nuclear power incident and so forth, I know that the infrastructure was damaged during that time frame. Did your office play a role in reconstitution or restoring or retaining services during that incident that lasted for a while?
So capacity and diversity equals survivability. So DISA always plays a part in those analytics, as well as the systems that we use and how we utilize them. We also advise the combatant commands on capabilities that they may already have to make sure their mission essential traffic can go through in any place of the world. So it's working with the combatant commands and the services to figure out exactly what their requirements are, what they need at any one given time. I said it before, Frederick the Great once said, those who protect everything protect nothing. So now you get into what is the most important thing that has to be on all the time. So we've worked very closely with the combatant commands and the service components on that. Our network, as we put them together, we try to make them as diverse and as robust as possible so that a single fiber-seeking backhoe, a single earthquake, a single bad guy trying to do something is not going to impact all of DoD missions. I will tell you, I've been doing this for 40 years of my life. I will tell you, in the 40 years of my life, I can think of only 3 times that we've had a catastrophic communication outage, and it hasn't been since I've been at DISA that's impacted a warfighter capability. So, capacity and diversity equals survivability. So understanding what the architecture is, how we utilize what's out there, how we diversify that stuff, how we make sure that a equipment set or a building or a cable or a whatever isn't going to impact that mission. That's what we have to do. Any other questions? I'm telling you, I wanted to give it back to you today. Oh, come on, that's funny. All right, guys, thanks a lot. I appreciate it.
Fred, thank you very much. And before you leave, I just want to say one of the themes that came out of this is let's make Rome great again. All right, I tried.
You're a tough crowd, I'm telling you.
So thanks again for being here today. There's a number of sessions that are just like this that are going on around the exhibit floor. At 3:45 to 5, we've got a panel this afternoon collaborating to drive innovation. So you might want to pick up that. It's in the keynote area where lunch was held just recently. And again, that's 3:45 to 5. And have a great afternoon. Thank you very much. Please get scanned on your way out for attendance today for extra credit.